boop, 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 boop. All right, there we go. What's up, Ethan?
Hello.
Here, let's get unaccessible up here, dude. What's up, dude? All right, let's up music. Oh, why am I sneezing so much? The fuck. Okay. How'd you unaccessible? Did you have a test yesterday or what? The day before yesterday?
Yeah, I had a test
Okay.
Tuesday.
How'd it go?
I didn't get to finish it because it was a bit too hard, but
Oh,
I
fuck.
finished it today.
Okay. Oh, so
Yeah,
you get?
it was extension because it was a half day, so we got 15 more minutes.
Oh yeah, you said that. Yeah, you had a half day for that exam, so you're like, shit, I don't know how we're gonna finish it in time, right?
Yeah.
That's cool.
Luckily, she gave us time to finish it.
Was most of it pretty easy? Could you like figure stuff out?
I mean, I could figure the angles out, but it was pretty hard. The parallel and stuff, so I just wanted to make sure that I understand it a bit more.
Oh, awesome. Okay, yeah, cool. Yeah, let's kick it off, dude. Let's answer your questions right now, cause you know, I'm down. Let's get right into it. Here, let me start off the
Sorry
stream.
if I
You're good. All right, welcome everyone. Office Hours, Main Dr. Gold, Zach Education, the stream that helps you out with math homework, science homework, all types of fun stuff. Yeah, sweet. I'm joined by a lot of people here, whatnot. What's up, Ethan? What do you want to say before I help unaccessible?
So yeah, you know how my physics class has been?
I don't know how your physics class has been, but I saw you did
Like-
better.
like,
I saw you did better. You're doing better in your classes, which I think is great.
That's dope.
Yeah, we're doing a lab report, you know.
Okay, how's the lab report going, dude?
It's going fine. It's just that I'm kind of taking it a little slow and steady because he does now penalize stuff. Because
Okay.
it's like this is our fourth lab, and the first 3 labs he wouldn't really penalize much since we're just new to it.
Okay,
But now I'm trying to take things slow and steady because I don't want to get penalized for work.
That's
I'm
all
trying to
good,
I'm trying to get an A. That's
let's
it.
help you out, dude. Let's help you out. Oh, Josue's got questions too. Hell yeah, dude. We got so many good questions today. I'm super happy. Yeah, dude. Yeah, let's help you out, Ethan.
You
Dude. I got
can't
you.
help me.
I can always help you, dude. I can help anybody. I just can't help myself.
You can't help me. Seriously.
Dude, okay. All right, here. Let me help unaccessible. Okay. Okay. A vertical line intersects a point. Write the equation of the line in standard form. Is that what you got?
Yeah.
Vertical line. Wait, what the hell's a vertical line? Oh, I get it. Yeah, a line that goes up and down. Yes. Okay. Do you know what the equation is for lines that go up and down?
It's just x equals integer.
Yeah, x equals something. Yeah. What does that x equal usually? Like in the case here where they say it intersects the point 39, 21, right? What would we say x is equal to?
I mean, the 39 comma. I would say like x is equal to. Oh.
Yeah, what's it equal to, dog?
39.
Yeah, exactly, dude. Yeah. So this point here, right? I don't know, whatever. Let's just like say 10, 20, 30, 40 or whatever, right? 10, 20, right? That point is like somewhere over here, right? This is what like 39, 21 would be, right? Let me put it way over here. Sorry. And if you want a line, right, unaccessible that like goes through it and that's vertical, you want it to do this, right? Does that kind of make sense?
Yes.
Okay.
So,
And this is just the line x is equal to 39 is what it is. What if I wanted the vertical line? Sorry, the horizontal line that goes through this. What if I wanted the horizontal line? What would that be?
you put y equals 21.
Exactly, dude. Yes. Yeah, because then that would just be this one, right? That would be just... Well, here, let's put it down a little bit. There you go. Whatever. It'd be above 21. Let's say it's like... I can't move things. Exactly. There we go. Cool. Yes, this would be y is equal to 21. Exactly. Was there anything else that was like kind of harder like this on your test?
Yeah, we had to find like so there's like a x equals, it was like in fractions,
Okay.
like a
I don't know, like x equals like 3/2, comma like 5/4 or something.
No, not like that. It was like a standard form. You had to organize it, but I didn't really understand it.
Okay.
It was like three, no, not three. 1/3x is
Okay.
equal to 2/9y
Like this,
minus
where the X is on the top or the bottom. Do you remember?
like on the on the um, no, I meant like a standard form, so like it's on the right.
Like this?
Yeah.
Okay, cool. Okay. And then what? They probably had like a -6 here or something.
Yeah, like -6.
Sure. Okay. Yeah, so you have to know like what standard form is for a line, right? Which, you know, I'm used to like what we call like slope-intercept form, right? So that's just like y is equal to mx plus b. I believe like what the fuck is standard form for a line, dude? What standard? They come with all these like, you know, whatever. Oh, ax plus by equals to c. Okay, cool, awesome. All right, got it. All right. So this is what standard form is here, unaccessible. It's ax plus by is equal to c, and then they force you to make sure that a and b are not fractions. They have to be like whole integers. Okay? What's up, Teacup? Does this make sense? What this is like this, right?
Yes.
Okay. So I'm gonna like take some stuff and move it around, right? So the first thing I'm gonna do is I'm gonna like pull this thing over here to the left, which is gonna be 1/3 x minus 2/9 y is equal to -6. Okay? Do you see how this is kind of closer to standard form because I have something x plus something y, right? Something x plus something y is equal to c, some number, right? But something's not quite right here. What's not quite right, Unaccessible? Why does this not look exactly like this? What's wrong?
They're fractions.
They're fractions. All right, how do we get rid of fractions?
You multiply by the reciprocal.
You can multiply by the reciprocal. Yes. So, but then it's like which reciprocal do you multiply right? Because like these are both numbers, right? So I can multiply by like 3/1, or I could multiply by like 9/2. Right? So what you want to do is you want to multiply by what's called the least common multiple, okay, of these two denominators, okay? So that it's called the least common multiple. Do you know what a least common multiple is?
Yeah.
Okay, so what's the least common multiple of 3 and 9?
9.
9. Good. Yeah, it's like what number do these things both go into? 9 goes into 9, right? And 3 goes into 9. So cool. So that's what I want to multiply and when I multiply, I need to multiply everything on the left by that and everything on the right by it, okay? So what I'm doing is I'm doing a big like 9 times all this and then a big 9 times all this. Does that make sense so far?
Yes.
Okay. So this is easy, right? Because what's -6 times 9?
-45.
No,
I mean,
close.
not
That's
-54.
-54. Good. Okay, good. This is -54. And then what do I do with this? What happens here?
You multiply the numerators.
Good. So this comes through and multiplies the numerator, right? So that's 9/3x minus 18/9y, right? Hi, Dr. Cole. It's all right, Dino. What's up, dude? Okay. This is almost done, okay? But then do you see how I can simplify these things?
Yes.
What's 9/3?
3.
3. So we got 3x. And then what's 18/9?
2.
2. 2y is equal to -54. And you are done.
That's dope.
Yeah, cool.
Yeah.
Does that make sense?
So, yeah, so when the y is on the right side and there's only x on the left side,
Sure.
you can just like take away the y and put it on
Yeah,
the
all
right
I did
side.
here is I just subtracted this. I just subtracted this to move it over. If this was a negative, for instance, then I would add 2/9y to both sides.
I don't know why, but I thought that when you take away something and you put on like the other side, it has
Yeah.
to be on the left side for some reason.
It doesn't really matter. I mean, I know what you're talking about. You're saying like if I have this, I have like 1/3 x is equal to 2/9 y. So there's two ways to do this, right? So I can do it the way I did it, right? Which was minus 2/9 y minus 2/9 y. And then that looks like this, right? 1/3 x minus 2/9 y is equal to 0. But I can also do what's called like, I can say, okay, I'm going to add negative 2/9 y to this side, and I'm going to add negative 2/9 y to this side. And so what this becomes is this is negative 2/9y plus 1/3x. It would be equal to 0. You see how this right here is the same as it's the same as this. Like these two things here are the same expression. Like a minus b is the same shit as negative b plus a, because you can just like take this thing. This like has an imaginary plus in front of it, and you can just like put it over here if you want, and then it's the same thing. Cool. Does that make more sense to you, dude?
Yep.
Dope. You're welcome, dude. Yeah, always ask me questions. Anything you got, dude, like throw them in you did the right thing, throwing it in the screenshot channel. That's awesome. And you get a bond coin for that, which puts you at what? 2. Nice, good.
Nice.
Once you get 10, I buy you a $10 gift card. So keep asking questions and you get prizes. Nice.
Yeah, one other thing. You know,
What's up, dude?
I had trouble. I had trouble. That's a joke, but I had trouble trying to find how to add a screenshot, because I took a screenshot. Like, I wrote something down first,
Sure.
and then your bot told me, "Oh, it got deleted."
Oh yeah,
because you can't.
yeah. You can only put images in that channel. Yeah.
Yeah, so I was wondering. So then I took a picture of it.
Perfect.
And then I tried to send it in the images
Yes.
again, but then it didn't work. You want to know the problem was?
What?
I pressed file. I sent it as a file. I was stuck with that for like 20 minutes.
Yeah.
Wondering, why isn't this working?
Yeah, no, that one only. Yeah. So yeah, those of you that are wondering, yeah, the reason why that is here, I'll show you. It's on. Yeah, let me pull the Discord up. Yeah, that's this channel, the Help Screenshots channel. Yeah, this only allows you to post screenshots of homework questions you have, because otherwise, dude, there's too much like shit posting text stuff that happens, and like this is the way I like. It's clean, and like I know like what questions we're going through, because every other channel, like someone starts arguing about Naruto or something, and like I don't know, like I'm just like I can't find the question. So yeah, you did the right thing. You're good. Okay, cool. Let me pull up Jose's question. Jose, you want to come to the stage? You got a mic? You want to talk? You don't have to talk, but it's cool if you do.
Have a good day.
You too,
bye.
man. You too, Inaccessible, dude. Glad to help, man.
Bye.
Bye. Bob is on a 7 stream streak. That's dope. Amog wants to say, "What's up, Moog? What's up, Amogi?" Oh, Jose doesn't want. There we go. Jose. I don't know. I'm terrible with names sometimes, man. I just say my name is Gold, and it's just easy enough. I think I invited you, Jose, but honestly, like, yeah, the Discord needs to fix their stages, dude. Their stages like screw up all the time, man. It's like hard for people to figure it out, especially on mobile. Okay, here, let me get all his questions though. One sec. I see. That's 12. This is 13.
When are we doing my question?
Soon. Let me do everyone's questions that hasn't asked a question yet. That's what I prioritize first, right? It's first time students, and then we'll go over yours. Cool.
I see.
All right.
Sweet. All right. Oh, Jose made it to the stage. Dope. Does your mic work, Jose? Josue? Yeah. There we go. You're in. What's up, dog? You in physics? Oh wow, this looks complicated.
Yeah.
Damn, dude.
It's a weed out class. Yeah.
Dude, why did your teacher choose violence this morning, dog? Like, this is
Sorry.
no, it's okay, dude. Like, but
Is this really physics here?
this is physics. It is. I mean, it's nightmare mode physics, but yeah, it's physics. It's okay.
It's
Is this mechanics? Is this mechanic physics or something? AP
Correct.
physics?
It's mechanics.
Yeah, this is
Dang.
physics 121. Nerd.
Oh, this is a college. It's a college physics class. Yeah.
Yeah.
Okay. All good, dude. Yeah. I get you,
Make it
dude.
challenging on purpose.
They do. Lecture long answer question. Like what? Like so? Like this thing's supposed to take the full 90 minutes, dude. I wouldn't want to do
they
that.
have part 1 is just multiple choice.
Okay. Cool.
You can't get partial credit, which sucks.
All good. All right. I think we're gonna do like conservation momentum and stuff here, probably. Because I see masses and velocities. Have you done conservation momentum yet? That's a good question. Or are you
More than likely.
okay? Well, yeah. So here's always like a good question. Have you done conservation of energy?
Yes.
Yeah. So you have kinetic energy, whatnot, conserve all that stuff. Yeah.
Yeah.
Okay.
Yeah. Right now we're learning about transitional engineering.
Okay.
Transitional energy, kinetic energy. Yeah.
Okay, cool. Okay, I get it. Yeah, okay, good. Then yeah, all right. Okay, consider a system composed of two carts, A and B, with inertias MA, MB. I assume that means the mass, not the inertia. Inertia is usually P, which is MV. I don't know, maybe there's a typo here in this. And the spring between the carts with negligible inertia. Again, I think they mean mass. Wait, what country are you in? Are you in Canada?
No, U.S.
The U.S.? Why the fuck are they calling this inertia? That's weird, but okay.
That's how they get you confused. Yeah.
Dude, that's just wrong. Like inertia, inertia. Well, that's momentum. Sorry, it's m times v. Sorry. Yeah, okay, I get it. This is what's called like linear inertia, which is technically mass. Okay, you eventually get to learn what's called angular inertia or moment of inertia, and that's more actual stuff. Okay, whatever. Okay, cart B moves frictionlessly on top of cart A. That's good. And cart A moves frictionally on top of this. Yay, there's no friction. Initially, both cars are at rest, and the spring is compressed. The spring is attached to cart B, but not to cart A. Oh, so like this thing is only stuck to this, is what we say, right? When the spring is released, but before cart B falls off cart A moves with velocity VA relative to the ice, and cart B moves with velocity VB relative to the ice. Determine if the system is open or closed, isolated or not isolated. Explain why. Okay. These are like fancy terminology things. Like, who cares? What? I think the system is closed. Let me look up what the exact definition of like closed. Usually, it's like, do we let energy flow in and out? Is usually what we say whether something's closed or open. System closed, open, isolated, not isolated. Yeah, I don't know. I have to just look up real quick what these terms are. Isolated. This is a system in which no matter energy is being exchanged. Cool. Only energy is being exchanged. Okay, awesome. Okay. Both matter and energy is okay. Oh, what the hell? Okay. Here we go. Here's a nice, cute little picture of what they're asking. I sometimes need pictures. Okay. So, exchanging energy with the surroundings. Okay. So, this occurs whenever you have friction. So, anytime we have friction, that means energy is going to be lost to the surroundings in the form of heat, right? Or something else. Mainly it's just heat. And then exchange of matter with the surroundings, that's when things literally like break or are like reformed. And so, an example of that would be like a bullet like going through a block or something. That's going to like displace some matter, and some matter is going to go places. So, yeah, I think this is isolated. I definitely think it's isolated, and and it's closed. Is what I would say. Yeah. Yeah, because it's definitely not an open system. 100% not that. I think it's closed and isolated. That's what I would say. And if they ask you why, you can say that there's no exchange of matter with the surroundings. And you can say no exchange of energy.
Just to give you context, this is like for my past exam, and I said it was I said the system was isolated.
Okay.
I said the system was open because I thought like the spring
Okay.
like was doing something, but then yeah, now that makes sense what you were just telling me.
Yeah, so you're right. So energy is transferring from the spring to the carts in terms of like velocity and whatnot, but the carts are still like part of the system, is what we say. The surroundings, that would be like the ground here or the air. That's what we call like the surroundings.
Okay.
And the only way you can exchange energy there is to have like heat. And heat really only comes from friction. Exactly. Yeah.
Right.
Yes. Okay, cool. So I think that's that. Cool. Easy. Bingo bango.
Nice.
All right, let's go to like the actual hard stuff you got to do though. Okay. Calculate VB. Yes, this is where this gets hard. Calculate VB in terms of MA, MB, and VA. Show your work. Okay, cool. First thing I'm going to do is conservation of energy. Okay. And you have to pick like a reference is what you have to do. Okay. Do you know what it means to like pick a reference?
Like a formula?
It means like where am I going to measure things from? Okay.
Oh, okay.
So when I think about the velocity, right, VB, for instance, that's the velocity of B referenced, I believe, to the ground. Yeah, see, they say relative to the ice, and this is relative to the ice, okay? Because let's say cart A was moving forward at like 10 meters per second, and that cart B was moving forward at 20 meters per second, okay?
Mm-hmm.
Then the relative velocity of VB relative to A, that would be only 10, because it'd be 20 minus 10. But we're going to measure everything referenced to, like, the ground. We call this a stationary reference frame. That's the big fancy word they say. It's like you're measuring...
Oh, yeah, I remember this. Yeah.
Good, yeah. You're measuring it relative to something that's not moving. Otherwise, yeah, things get more complicated. Okay. Okay, so what I'm going to use here first is I'm going to use conservation of energy. Okay? And I'm just doing that just off my gut reaction because, dude, anytime I see mass, anytime I see velocity, and I see, like, there's a before and there's an after, I think about what things are conserved, like what things are the same before and after. And that usually gives me equations that I can then solve things. Okay?
Okay.
All right, so let's write out what the energy is like before. And let's write out what the energy is afterwards, okay? So, before, what's happening before in this situation? What's like crack-a-lackin' in cart land? Like, is cart A moving? Is cart B moving? Are any of those things moving?
Isn't car A moving first?
So it says, initially, both carts are at rest, okay?
Mm-hmm.
And the spring is compressed. Good. So what does that mean about, like, the energy that is there? What types of energy are present when the carts are at rest and the spring is compressed?
So you got potential energy on the compressed spring, right?
Good. Yes. So you have 1/2 kx squared, for sure. That's the spring. And then do we have any other energies?
I'm guessing the kinetic energy.
So they're both at rest. So we see how we say initially they're both at rest. That means their velocities are 0. Okay. And if you remember, kinetic energy is 1/2 mv squared. If all the v's are 0, all the kinetic energies are 0.
Everything is 0.
Cool. Exactly. Yeah. So this is the only energy there is. I mean, technically there's gravitational potential energy because, like, these things have heights to them. But since these things aren't going to move, like, they're not going to change heights, like, between when they're starting and when they're ending, we don't need to worry about it. Technically, if this thing, like, flies off and, like, goes down here, like, we do need to then worry about gravitational potential energy, but we're just talking about when the cart's here, it's compressed, and then afterwards, when it's like it's flying along the other cart, but it hasn't dropped on it. It hasn't dropped off yet. Okay?
Okay.
All right, so this is before. Okay, afterwards, right? What energy is there afterwards after the spring is released? Do we have any spring energy?
Spring's released. Yes.
Why do we have spring energy? The spring's been released.
Oh, so there's none. So it goes to 0.
Yeah, it's 0. Exactly, good. Yes, so spring energy is 0, right? Because the spring has been uncompressed, okay?
Oh, okay.
But what other energies are present, though?
Before card B falls off card A. So there's some velocity in V
Uh-huh. What else?
relative to the ice, and then card B is also moving, so there's velocity on card A and B.
Good. Good, exactly. So I'm gonna say 1/2 ma va squared and 1/2 mb vb squared. Those are both things that have energy. Okay. All right. Cool. That's my conservation of energy, which is nice, right? Okay. Cool. Now they want VB just in terms of masses and velocities, okay? Which we almost have, right? I have VB here, I have masses, right? And I have velocities. The thing that's kind of annoying here, right, is that I also have this. I have this KX thing, right? It didn't say I could do things in terms of KRX, right? No. So conservation of energy is not going to work to get this. We're probably going to need it later for this, for question 14. So it's good to write this out just to start, okay? But the other thing we can use, what's another thing that's always conserved in situations like this?
Gravity?
Well, gravity's gravity. That, yeah. let's go through the things. You got conservation of energy. You got conservation of something else. It starts with an M.
Mass.
Mass is conserved. That's true. You're okay, teacup. What's the opposite of dad?
Dad?
Yeah. Well, like, yeah. So I'm trying to get you to say mom. Yeah. Okay. Cool. And what physics word starts with mom?
Matter?
Momentum.
Momentum.
Momentum, I guess is what it is. Yeah. Okay. Cool. All right. Conservation of momentum. This is the other one. When you're doing mechanics, like, these are the two things that you're probably always going to use, like conservation of momentum and conservation of energy. Okay.
Okay.
What does conservation of momentum say?
Oh, I have a sheet here.
No, you don't need a sheet.
Oh.
You got this, dude. You don't need a sheet.
Momentum
I know it.
say-
Momentum stays the same. And what is momentum? How do you measure momentum?
Is that a scalar or a vector?
Momentum is a vector, technically, but we're going to deal with it just as a scalar here, because everything's just in one direction, which is okay.
Oh, okay.
So momentum, right, that's equal to m times v, is what it is. Mass times velocity. Okay? Yes. So, and what you have to do is you have to add up the momentums of everything before and the momentums of everything afterwards. Okay?
Okay.
So, we're going to look at the momentum before. So the momentum before is just 0 because none of these things have velocities, right? Remember when we did conservation of energy? We're just like, nothing's moving, right?
Right.
So that's going to be 0. But then afterwards, okay, you're going to have MA VA plus MB VB, right? Because, yeah, so this will be the momentum of the A thing, right? And this will be the momentum of the B thing. And the total momentum before has to equal the total momentum afterwards. So that means that these two things have to equal each other, right? So I get 0 is equal to MA VA plus MB VB. And then what was the question asking you to solve for? What did it want?
Calculate for VB?
Yeah, it's good.
So it's like algebra from then.
Yeah, it's just algebra. Yeah, easy peasy. Yes. Well, nothing cancels out, but it's MA VA over MB is equal to VB.
Oh, right.
Yeah. So I just moved this over and then I divided by this. Cool? Good. Awesome. You should notice something cool here, right? So the velocity of the B block, how is it related to the velocity of the A block, like direction-wise?
Both go the same direction?
They're going to go opposite directions. Do you see how there's a negative here? Negative, yeah. The negative means an opposite direction. This is why momentum it's technically a vector here, but it's plus means one direction, negative means the other direction.
Oh, I see.
So what that tells you is that, like, when this thing happens, right? This thing, the top one's going to go one way, and the other thing is going to go another way to the left. Okay? This is the same question. Have you ever seen the question where like there's the person in the boat or some shit, and then like they like throw another person off the boat, and they're like, "Oh no, dude," and then like the boat starts moving to the left because the person they threw moved to the right.
We have gotten those questions.
Yes, that's a classic question. Yeah, that has to do with conservation of momentum too. And yeah, exactly. Yeah. Okay. Cool. Awesome. All right. So that makes sense so far, right?
Mhm.
Okay. Let's look at calculate the velocity of VA from a reference frame that is rest relative to cart B in terms of MA, MB, and VA. Show your work. Okay. Cool.
This is the part where I struggle.
Yeah, the reference frame is annoying. It's annoying. Okay. Okay. Calculate the velocity of cart A from a reference frame that is at rest relative to cart B. Okay. So now what they're saying is they want... So before, when we were doing this, right, we were measuring all of our velocities from here, from the ground. Okay? Now we're measuring all our velocities from cart B, like the velocity of cart B. Okay? From where cart B is, okay? When it's moving. All right. This is where things get kind of weird, okay? So here, let's draw. So this is cart B, right? And this is cart A, right?
Mm-hmm.
And we're measuring it relative to like this frame, where this is like this is basically standing still, okay? But this cart, right, is gonna be moving to the left. Okay? Yeah. Okay. So here's the thing. All of the velocities now are measured reference to like a moving cart B. Okay? So like this thing is technically one second, can I grab both of them? Yeah. This thing is like technically moving to the right is what we think of, and that's how we measure velocities. Okay? So, okay. This is where we have to kind of like look at, again, momentum before, momentum afterwards. Okay? Okay. This is really annoying that they do this to you, but it's okay. Before, momentum afterwards. Okay. So, when these two things are technically at rest, right, not moving, okay, what is their velocity going to be relative to something that was moving to the right at VB? Like, let's say, like, I'm a person here, and I'm sitting on a platform, and my platform's moving this way. Which way would you see these things going?
Positive?
You would see these things going to the left, right? Like, they would...
So cart A would be going to the left?
Cart A and cart B at the beginning, right?
Oh.
Because at the beginning, these two things are staying still, technically, relative to the ice. But you're moving to the right, okay? Have you ever, for instance, been in a car that is, like, I don't know, moving... You're in a car, and, like, another car is, like, moving... It looks like it's moving backwards because you're passing it, right?
Right.
That's what it's like. You're in a car that's moving, and when you look at the car next to you, because it's slower, it looks like it's moving backwards relative to you, but it's not. In this case, you're on something that's moving, so anything that's stationary looks like it's moving away. Okay? And everything that's moving away is let me think.
Okay.
That's going to look like it's moving away at VB. So this is going to be minus MA VA and then minus MB VB. That's like relative to my frame. That's what I'm going to see it as. Okay?
Right.
And then afterwards, okay, I'm going to see my velocity as 0. Right? Because I'm measuring velocity from where I am, which is like moving to the right. So instead of MBVB, this is just going to be 0. All right, sorry.
Okay.
This is MAVB. Sorry, is what this is. And then this one I'm going to see as minus MAVA. Yeah. Because this is the other thing you have to realize, Jose, is that like these things, right? Since they're both stationary, they both have to have the same velocity. And
Okay.
that's why this one has this negative VB velocity and this one has this negative VB velocity. Okay? So now you can solve for VA here, because that's what they want. They want the velocity of cart A. Okay. And so whatever these are, what is this going to be? So this is negative MA VA is equal to negative MA VB minus MB VB, right? So that's so ugly. VA is equal to MB VB minus MA VB all over MA. I think this is what it's going to be. It's kind of ugly, honestly.
So when something is stationary, it's gonna move in the same direction. So A and B before is moving to the left, right?
Good. Yeah, that's right. That's why these are both negative. See how these are both negative?
Yeah.
And then afterwards, right, I'm going to measure my velocity on B as 0 because I'm moving at that velocity, right? I'm moving at the velocity that I'm measuring everything relative to. But this thing is going to look like it's moving even faster to the left. Yes. Yes. Yeah.
Okay.
It's
So is
weird.
that because
That's such a weird question. Why would you ask that question?
one is fail? I don't know.
Dude, that's fucked up. Okay, but what were you going to say? What's up?
So B will be essentially, I guess, it'll be 0 because it's going to the opposite direction.
This one would be 0? What do you mean? Sorry, this one is 0?
Yeah.
This one is 0
Yeah.
because the frame that you're measuring velocities from, right,
Mm-hmm.
is the frame of the B block moving to the right. That's what it is.
Oh, okay, I see.
Jamarcus says, yes, because it is a reference frame. Jamarcus says physics sounds annoying. Yeah, this is annoying physics. This is just hard for the sake of being hard. There's no reason for it to be this hard. Like you don't need to start changing reference frames. Like, but your teacher's doing it to you. That's why it's usually not this bad. Okay. Yeah, what's up, dude?
I wouldn't have a chance at solving this at this level.
It's okay, dude. I'm honestly probably doing it wrong too, honestly. Like, do you have the answers to this one, Jose? Actually, do you have the answers? I'm curious.
I think so.
Yeah, if you get them, could I see them? Because, I'm pretty sure I'm right, but, stuff like this is tricky just to be tricky because they're just trying to screw you up. And I guarantee you they probably are screwing me up somewhere.
I'll have to check.
Okay. Calculate total convertible energy from a reference frame that is at rest. Give me a second, Ethan. That is at rest relative to cart B in terms of this. Total convertible kinetic energy. What? Excuse me? Oh, I see how this works. This is kind of cool, actually. Okay.
Is this something I could probably go by?
No, you can't have any. No, no, this is too hard for you. Okay. Okay, Jose. So total kinetic energy, right? That's 1/2 MA VA squared plus 1/2 MB VB squared, right?
For the convertible kinetic energy.
Yeah, don't worry about convertible. Just say like total kinetic energy. I don't know why they say convertible. Don't worry about it. They say total kinetic energy. That's where we should.
Kinetic energy.
Yeah, it's this, okay? But here's the trick, though. Do you see how we're doing it from a reference frame that is at rest relative to cart B, okay?
Mm-hmm.
What does that mean the velocity of the B block is going to be?
Oh, 0.
0. Exactly. So this goes away, all right?
Oh,
So you see how now this is your kinetic energy?
yeah.
And it's just in terms of VA, and that's what we calculated up here. We calculated VA if VA was referenced to the moving VB.
Mm-hmm.
So that's why VB is 0, But in this case, VA is no longer something nice, right? It's something weird, right? VA would have been this. Look, VA should have been equal to minus MB VB over MA. Like, this is nice. I like this, right?
Nice.
This is not this looks nice, but then this is what it becomes if you start referencing it not to like the stationary ice. If you start referencing it to something else that's moving. Yeah. So then all you're supposed to do is you're supposed to plug this into here. And so you get 1/2 MA. So this is actually going to cancel, which is nice. See how the MA out here cancels out the MA down here?
Yeah.
Oh, but it's... Yeah, no, sorry, but it's squared. Oh, ew. Okay, never mind. Never mind. I got ahead of myself. Okay. Can you pull anything? Oh, you can pull a VB out of this, which is cool. So you can pull a VB out. And then this is MB minus MA over MA all squared. Oh, wait a minute. But we can't have a VB in here. Oh, wait. One sec. What did I do wrong here? One sec. Okay. Before... Calculate the velocity of cart A. So, yeah, the reason why I know we got tripped up here is because our velocity here, VB, should only have been in terms of MA, MB, and VA. But I had a VB term in there as well, so that's wrong. So we can't do that. Let me think about this one a little bit harder, sorry. All right. Calculate the velocity of cart A from a reference frame that is at rest relative. Okay.
I found the answer sheet.
Yeah, can you send it to me? Can I see it? I gotta think about this. I remember that is at rest relative to cart B. Oh, I see. I think it's from a reference frame that is at rest relative to cart B at all times, is what it is. One second. Did you...
There you go.
Cool. Perfect. Yes, let me see this. Yeah, here we go. This is what I want to see. Yeah. No. Okay, cool. All right. Yeah, this is the VB naught, dude. What? Yeah, okay. VB naught is equal to VBA plus VA naught. Okay, well, let's make sure we got this right. VB is negative VA, yeah, MA over MB. Okay, good. So we're good here. Okay. Calculate the velocity cart A from a reference frame. Okay, so they're saying that... Okay, so VB naught, okay. So that's... So here, they don't even want us to do the before and after momentum. They just want to do it from here. Okay. So... This is like the VB original, and this is the VA original, right? And they're saying that, I guess the relative velocities, because these are all measured to 0. And they're saying VA naught. Oh, okay, 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 okay. Okay, I think I started to see this. This is so weird. Okay. Um. Okay. 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 They're saying the velocity of B in a reference frame that is not moving is equal to the velocity between the relative velocity of B to A plus whatever the velocity of A is in a reference frame that's not moving. Where's that coming from though, dude? Calculate the velocity. Calculate the velocity of B. Yeah, okay. Yeah. But then they're saying VA0 is this? They're saying VA0 is equal to negative MB over MA VB. Let me think if that makes sense. Oh, okay. Okay, no, this does make sense. Okay. Sorry. Okay. VAB is the velocity of A referenced to B. This is what's called like the relative velocity. Okay? And that's equal to the velocity of B by itself. Like the velocity of B measured to the ice minus the velocity of A measured to the ice. That's what the relative velocity is. So think about this. If this thing was going at let's say 20 meters per second this way, and this thing was going at 10 meters per second this way, how fast does this thing look like it's going from this? 30.
Oh.
Yeah, because say this was standing still, right? This would look like it's going away at 10. But say this one is also going to the right at 20. Do you see how the velocities add?
Oh, they add.
This becomes 20 minus negative 10, right?
Mhm.
Okay. It's like the car situation, right? If I'm in a car, right, that's going 60 miles per hour, okay, and I have another car that's slower and is going at only 10 miles per hour, or sorry, 50 miles per hour. How fast does it look like I'm going compared to this?
How fast is it?
Like relative to the 50 mile per hour car, how fast does it look like I'm going?
Like 10 miles per hour?
10. Good, yeah. You see how you subtract this one from this one? So this is 60 minus 50 is equal to 10. Okay.
Mhm.
Let's take the opposite example. Let's say, like, I don't know, you're just have a death wish or something, right? And, like, you're going at 30 miles per hour and you're going towards another car head on that's going at 40 miles per hour, okay? How fast does it look like this car is going to hit you?
It'd be like 70?
70. Good. Because what happens is this is 30 minus negative 40, which is equal to positive 70, okay? This is also why, like, head-on collisions suck. Like, if you're just going 20 or 30 miles per hour, cool. But if you hit something else that's coming at you at 20 or 30 miles per hour, now it's as if you were to hit the wall at twice the speed. Okay? This is what we talk about with relative velocities. So the relative velocity between B and A is the velocity of B minus the velocity of A. Okay? Where these velocities are measured from, like, a stationary point, like measured from the ground. So this gets me that VB0 minus this, right, which is minus MB VB MA, right? That's equal to VAB. Okay?
Okay.
All right. Yes, good. So this is the relative velocity that it sees it. Yes. Okay. So this is what I'm solving for. Okay, so then how do they say that VB0? Okay, wait. He says VAB equals VA equals VBA equals negative VA. This doesn't seem exactly right. I agree with this. I do not agree with this. I don't think this is right. I think this is what you're solving for. You're solving for the relative velocity. The question is, and then wait. We're only allowed to have it in terms of VA though. Oh, okay. Okay, one sec. I see where this is coming from. Yeah, that's coming from this. Okay. We solved for this. This is like VB0. This is VA0. Okay. Okay. And then VB0 is this one. Yeah, okay, I get it. So this one, VB0 becomes negative MA VA over MB. Okay?
Well, that makes sense.
Okay. Now this is just combining a bunch of... This is combining two fractions is what this is. Okay? So this is MB VB over MA plus... minus MA VA over MB, which if you want to combine these now, I got to multiply this by... Oh, but... Ow, man. But I can't have... Sorry, I can't have VB in my expression. Huh. Yeah, relative velocity. Oh, but one of these has to be 0. Oh, okay. Wait. No. Huh. One second. I'm okay with this because I'm allowed to have things in terms of VA. Okay, and then it's minus VA0. Oh yeah, but VA0 is just VA. Okay, that's dumb. Okay, got it. Okay. Yes. Okay. So originally, I'm sorry. This is a complicated, like, kind of mindfuck of a question, but the relative velocity, right, between A and B is equal to the velocity of B measured from the ground minus the velocity of A measured from the ground. Okay. This would have just been VB minus VA, but they want this relative velocity only in terms of MA, MB, and VA. Okay. So what I have to do is I have to change what this is. I have to change VB. And what we learned in the first part here, right, is that the velocity of B could be expressed as the velocity of A. By conservation momentum, it was this. Okay? It was the MA VA over MB. And, okay. And that's the velocity of A relative to B. Yes, okay. And let's think, like, sign-wise, if this makes sense. So, sorry, if this is, like, 5, and this is 0, yes, then I would see it going to... Okay, but what they want is they want VBA. And so VBA is the switch of this. So that's going to be VA minus negative MA MB over VA. So that's just going to be equal to MA over MB VA, and then it's plus 1 all times VA, which I think is what they get here. He gets a double minus. I don't like the double minus. Okay. Wait. Okay, no. The minus is okay. Because if we're stationary, the thing's moving to the left. Okay. whatever. Fine. Fuck. This is it.
No, yeah, they do that on purpose. Yeah.
They're messing with you, dude. Okay.
Yeah.
Okay. This is what it is. I'm trying to think, dude. Like, yeah, if my velocity is 0 and I see A moving at a velocity that's positive, I should see it being positive. So I don't get that. Maybe I probably have these. I think I have these signs switched. I think this is VA0 over VB0. Yeah. Okay. Okay. All right. Whatever. Fine. And then, yeah. And then you take whatever this value is and you plug it into here for 1/2 MA VA squared. And instead of VA squared, you put this nasty thing, which is, what is it? It's minus MA over MB minus VA minus VA. It also depends on like what you're calling positive and negative. Yeah. Original reference frame is the center of mass frame. All frames have the same convertible energy. Okay. Uh-huh. Okay, yeah, and he just does this. He just does 1/2 whatever the value was that you got for this. I think. 1/2 1/2 MA VA squared plus 1/2 MA over MB VA squared. Yeah. Wait a minute. Oh, but he uses VB as this. Oh, he says VB is this one. Calculate VB in terms of VA for reference. Okay, because VB is 0? I don't agree with this either, dude. What the hell is this? What the hell? Dude, fuck your teacher, dude. What? Oh my god, I've like killed my... I've killed too many brain cells on this question, dude. Okay, whatever. I hope the first two parts make more sense. I don't agree with his last part here. I think I don't agree with this. Also, I don't agree. I don't agree with him like asking like this tricky of a fucking question, dude. Like what? Like what? Yeah, don't fuck your teacher. I could get an SCD. Yeah. Fuck, dude.
No, yeah.
All good. Yeah, sorry. Yeah, I know this one took a long time.
Sorry.
No, don't be no. I like challenges. I like challenges, dude. You still get points for that. I did it help you at least? Do things make more sense or less sense to you? Okay.
No, you made me open up on the reference frame.
Yeah.
About that.
Good. Yeah, it's all the sign changes and whatnot like that screw up. Okay, one sec. I know Bob's got to go real soon. Let me do Bob's real quick. And then yes, I'll do Jamarcus's, and then yes, let me do all the questions real quick. Okay. Come on.
Isn't it that kills your brain cells?
What kills my brain cells? That question killed my brain
Isn't
cells.
it biology that kills your brain?
No, it's drugs and alcohol. Don't do it. Anyways, all right. Okay, here we go. Let me do this one, Bob. Bob, what's up?
Yo.
Write the following limit as a definite integral. You may use the properties of logarithms to help with your algebra. Do not evaluate the integral. Cool. All right. Okay. Do you know what, like, for instance, happens when we have the ln of A, B, C, D? What's that?
You can add them.
Yeah, you can add. Yes, Dark, I know you added them,
ln
but...
A plus ln B.
Plus ln C plus ln of D. Good, exactly. Yeah. Cool, awesome. All right, so let's do these. So, this I can split as 1 over n, and then this is going to be times the ln of 1 plus 1 over n to the third plus the ln of 1 plus 1 over n, or 1 over 2n
2 over n
to the third plus the ln. Oh, this is kind of cool. Do you see how this kind of looks like an integral? And yeah, let me see. Well, I'll show you. I'll show you.
like a Riemann sum.
It looks like a Riemann sum, does it not?
Yeah.
Okay. Now, cool thing here, right? Do you see how this to the third happens in all the ln's? Okay.
Mhm.
What happens when I have the ln of something to an exponent?
You can move it to the front.
Good. Yeah. All these threes are going to come down. Okay. So this is going to become 3 times all of this. Okay.
Mhm.
Good. All right.
Yeah.
Yes. And then, so this looks like the 1 over n, right? This is the width, right?
That's the dx.
Yeah, this is like the dx term is kind of what it is, right? And then we're doing 1 over, and then it's going up, and then it's divided. Oh man, I gotta think. There's a formula for this one. One sec. Riemann sum formula. Yes, but where is it? There we go. This is what I want. Yeah, this is what I want. I want this. Where's this image? Copy this image in. Okay. This is like the generic like form of what it is. I hope this is not super blurry. Okay, cool. Yeah. So it's f of some function delta x. Okay.
Yeah.
Where the dx is always the b minus a over n. Okay. And then this is f of, and then it's a plus b minus a over n times like k. Where k is the number that keeps increasing, right? See how this becomes like k is equal to 1, then k is equal to 2, and k is equal to 3? Okay, great. So we just have to kind of like, we have to like analyze like what is that here as well. Okay? So b minus a over n needs to come out somewhere. So I think that's this, right? I think 3 over n is equal to b minus a over n, right?
Yeah. Seems like it.
Yeah, it seems like it. Actually, I think just 1 over n, honestly. I think 1 over n is b minus a over n. Let's keep the 3 outside. Let's say the 3 is like chilling out here really far. Okay. Okay. The reason why I'm saying this is because instead of this like 1 over n here, okay, I'm going to treat this as 1 over n times k. Do you see how, like, for instance, k is equal to 1? And then here with this one, Bob, right, this is 1 over n times another, like, k is equal to 2. Right? Okay. Cool. And then, yeah. Then I see this, right? This is, yeah, okay. Whatever. 1 over n times k. Okay. So if 1 over n is b minus a over n, that makes sense because you see how my b minus a over n times k shows up again? 1 over n times k. Awesome.
Yeah.
And then this is the a. So this is the beginning of where the integral starts. So I know that this starts at what?
You said the A?
Yeah.
So is it 1?
It's good. It goes from 1. And then what does that tell me b is? So if a is 1, what is b?
0.
No. So I need b minus a over n to equal 1 over n. I know this is 1. Well,
2.
Good, 2. See how this, so b must equal 2?
Yeah.
Okay. And then what is f of x, right? It's f of something, right? F of all this shit. I know. So in this case, where do they put x's? Excuse me. Hello. Oh, x is what's happening. Okay. Oh, this is very cool. This is gonna be the ln of x, and then it's just dx is what it is. Okay.
Wait, why is it just ln of x?
Good. Okay. Because, so, for instance, if mine is f of x as an integral, all like this, that's equal to a sum where it's f of something, where it's a plus my b minus a over n times k. So here's what happens. This is ln of a plus b minus a over n times k. But this is still f of x. Like, this x sub k here, Bob, that's what all this stuff is.
Okay.
So they have a cool example here. Do you see how here they have like they have the integral of 6x squared, and then they have it equal to like some sum of 6, and then it's the 1 plus, right, b minus a over n k squared. The function is still something squared, but all this garbage inside, this a and this b minus a and then this k, that's all just x. And more importantly, that's just x sub k. That just picks out what x you're at, like what bin you're looking at.
Okay.
Yeah.
Wait, in the 3,
Yeah.
does that go in front or no?
Yeah. Don't forget the 3.
Okay.
Cool.
This is.
Yeah.
It would be hard.
This would be hard, but again, you've seen it. So again, this is the whole point of this. The whole point of like going through any of this is that like as long as you've seen it once, right, in physics, not in physics, sorry, in calculus, if it shows up on a final, you know what to do next.
Yeah.
Yeah. Cool. All right. Awesome. I hope that
All
helped
right.
you.
Thank you.
You're welcome. Oh man. No, not Matt, dude. Who is this Mad guy, dude? I need to like remove coins from Mad, dude. Like what? Ugh. Yes, Jamar. No, stop making. Stop clapping. No more clapping. Subtract. 1. Okay. I'm gonna add 1 to add amount 1 user Bob the. Oh, it's because it's Bobby the AI. It's the same fucking name, dude. All right, whatever. All right, Jamarcus. Yeah, let me help you before. I know you got to leave soon. All right, let me see. What do you got? What do you got? What do you got? Where's yours? Wait, did you point? Oh, simplify this, dude. Oh man, dude. What? Why? What? Who hurt you? No, not this one. There's a couple others. We'll see if we can get to these. All right. The quadratic ones, I did the 2 of them. Okay. Which one do you need help with? Yes, Nick, you're probably afterwards. As long as no one else has time constraints. Need help with this one, or this one? 1, 2, or 3? 1, 2, 3. You need help with 1. Okay, cool. All right, let's do it. All right, simplify the expression. Gross. Okay. Okay, so I want all these things to have common denominators, right? So I'm going to start with this thing having a common denominator. I'm going to multiply it by 2 over 2. So that's going to get me 2 root 2 plus 9 all over 2. And then I need this to have a common denominator. So what? That's plus 4 root 3. And then plus 2 root 6. And this is all the square root of all this stuff. Oh, great. I think that's how we do it so far. Watch there be like just some like ridiculous like Russian math trick to this thing. There always is, dude. Okay. Okay, so now I need all the roots to be the same, I guess. Does that help me? I'm trying to think if that does actually. Not really. Well, yes. Yes and no. Okay. This is the same thing as, so if I wanted to write this as a root 6, right? That means I need to bring in a 2 somehow. So that would be, okay, so 4 root 3 is the same thing as 4 over root 2, root 3, root 2. So that's root 6. Okay. These aren't gonna have the same denominators anymore, but whatever. Okay, fine. So this is 4 root 6 over root 2. This is 9 root 6 over root 6. And then this is 2 over root 3 root 6. Yeah, I feel like that's what you do here. Just like y. I could multiply everything by root 2. Okay, let me think. Now my common denominator is root 6. So this is going to be another, man, but I don't want to, yeah, but then I'm stuck again, because then I'm screwing up all my things again. This is 2 root 3 plus 9 over root 6 plus 4 over root 2 plus 2 all times root 6 all over 2, and then all square rooted again. Yeah, this is just a loop of pain. Okay, fuck. No. I want to see if this comes out with something nice. When in doubt, Wolfram Alpha. Love you, Wolfram. Okay. Is this what we did? Square root of 6, 2, 3. Alternate forms. I guess these are your alternate forms. I don't know if that really makes it any more special. Like it's not really more simple. Let's see. Maybe we had something close to that. Ooh, how would they pull that 1 out, though, bro? Wow, that's nuts. What's up, dude?
Hello.
What's up, dog?
I'm an M to Fortnite.
Oh, nice. Yeah, Jamarks, I don't know. What is this?
Spaghetti.
There's a trick they showed you? Well, they didn't show Wolfram Alpha. That's weird. Wolfram Alpha is like the most genius symbolic algebraic manipulator ever. So none of these answers are correct. I'm just curious. I think I put that in right. Square root of 6.
Or your brain damage.
So square root plus 2 square root of 3 plus square root of 2 plus 9/2. You don't know how to explain it? Okay. Well, I don't know how to explain it either. I don't know what like weird like Russian reality these people live in, but I don't think it's that. Yeah. Okay, cool. Tried. See if you get a solution for it. I want to see what that one is. Yeah. I don't really know what that is.
Don't
got-
look at chat.
I'm not gonna hit play on that, dude. I'm not hitting play on that, dog.
No, it's not inappropriate. I promise you, it's not inappropriate.
It's not inappropriate, he says?
I put that
Okay.
shit on my mom. I put that shit on my mom.
Your mom left you, bro. What?
Bro, shut up. Anyways, I'm trying to get bone lab mods again, but this shit's cancer, I swear.
Okay, why is it cancer, dog?
Bro, every time I try to install this shit takes 13 years just to load up.
Well, I'm sorry about that. One sec,
And
I gotta
bone lab's
find.
on vert.
I gotta find.
And your Warzone better be updated, because last time we tried to play, your fucking Warzone was 60 gigs.
My Warzone was fine, dog. I don't know what you're talking about.
Last time I tried to play.
All right,
We
so
got switched to Fortnite.
is it my turn?
I'm gonna do Nick's because Nick bought the me first. He did buy the me first. Yeah, so I got to do his first. I did Jamarcus's and Bob's first because they have to go. But
I'm
I know
going
Nick's here.
cubes. If you don't know what cube means, it means circle, underline.
Could you send me a
box,
screenshot of those
line,
alternate forms?
solid.
Yeah, sure. I got you, dude. Give me a second. I got you, dude. Screenshot of the ultimate forms. Wait, where did my thing go?
Third, left up, right down.
Basically, if you have square root of x plus 2 square root of y, and you have factors of y that add up to x, then it's the sum of the square roots of the factors.
Bruh.
Square root of x plus 2 square root of y? How does it even work? Then it's the sum of the square roots. I mean... One sec. Let me paste this one in too. No, Nick, can't come out of detention yet. I gotta figure out why you're in detention first. Things have been so peaceful, so I don't want them to not be not peaceful.
Who even put him in detention anyways?
I put him and Taco Cat in detention because they kept yelling at each other.
Okay.
Yeah, that's you know, that's when people get put in detention. Cubes. 7 plus 2 root 6 is 1 plus root 6. Really? Is that really? Is that real? Sorry, what?
My headset's 50% now. Can you update?
7 plus 2 root 6 is equal to root 1 plus root 6. Is that real?
Real?
No. I think he's saying this. It's equal to root 1 plus root 6.
That's your goal. I got a question.
I have cancer,
Be
dude.
serious,
Like, what? What is this, dude? What? Give me a second.
I was just about to ask, like, bro, did you have cancer in the past or something? Because your brain is fucking melting by the second.
Yeah, dude. Well, I keep getting, like, ridiculously hard questions today. It's okay. Before that, I don't know what's happening here.
We'll tell
Sorry.
them to stop giving you hard questions.
That's okay.
Hard. That's what
God gives his hardest battles to his strongest warriors, dude. This is true? Is this really true? How is this true?
Computer.
Oh, the square root of all of this. Is it? Is that true? That's some weird stuff, dude. I don't know these rules. Again, like, it's cool that you have, like, a class that teaches you this, but, like, there's absolutely no, like, fucking real world situation that you're gonna need to do this. Just no. Apparently it is. One sec. I want to say it real quick before I do next. One sec. Square root of square root tricks. I guess this is a trick. I don't know if that's a thing. Try plugging in Wolfram. What? Yes, Lurd. Dude, I'm glad you remember Lurd, dude. What was this square root of? What did we say here? Sorry, said it somewhere. Fuck. Square root of 7 plus 2 square root of 6. plus 2. Square root of 6. Okay. Is that equal to 1 plus the square root of 6? Is that what we're saying? Yeah, where's the Konami code, dude? Oh, this is true. Okay. That's cool, man. Wow. Quadratics 1 if I want a fun one. What was the quadratics one? Oh, okay.
Did the fucking Konami code inside of chat.
With roots equal to... Oh, with one of the roots equal to. Oh, with rational coefficients. Wait, that means it has to be like actual rational numbers? We're speaking facts, dude. That's too funny. Yeah, I'll try this one later. Okay, here. Let me help out Nick. All right, let's see. Nick's doing chemistry on his own, which is cool. All right, number 2. How many grams are there in 3.4 times 10 to the 24? And here, I'll give you Concoin, Jamarcus, for making my head hurt. I need Noise to I need Ramton to come back, actually. Ramton would probably be able to solve that.
You're so old that WWF still existed.
Oh, yeah, because that became
You know,
WWE, right? How many
guys,
grams?
Damn, you're actually that old. Holy fuck.
Chill, dude. Chill, please. This is number of particles. Yes. Good. Is 1 mole. 1 mole is that. Yes, good. Good job, Nick. This is correct. It's the correct way to do this. One second. Let me just speed run these. 3. What is the molar mass of MgO? Good. Yep. That's correct as well. Find the number of moles. 30 grams of that. Nope. No, this is not right. Nope.
Brain damage.
Okay. So here you're asking for how many moles is equal to 30 grams of H3PO4, okay? And so then what you want to do is you want to say that, okay, the molar mass of H3PO4 is, I assume your 98 is what you calculated here. So you say 98 grams of H3PO4 is equal to 1 mole of H3PO4. So in this case, it's just 30 divided by 98, Nick, is what it is. Thank you for the periodic table. I appreciate that, dude. But here, let's do it. So, that's 30 divided by 98, which is, what is that? 0.306? Okay, so this is 0.307 moles. Yeah, this is 0.307. And then, yeah, okay. So, Nick, yeah, so for all of these, you need to take, instead of multiplying by the number of grams, you need to do the number of grams divided by what this number is. So in this case, it's 25 divided by 20.08. So that's 1.25 basically. Yeah. Okay, cool. Yeah, same thing. Yeah, just do the division right. You're okay. Was that it? Was that all the questions you had? I could have sworn you had another page somewhere. Oh, here we go. 9 and 10. Yeah. Another key thing. Yeah, here, Nick. If you're getting these really, really big numbers, having 256,000 moles of something, that's a lot of stuff. You don't want to have that much stuff. Yeah. That's it's a couple tons or something, dog. Yeah. But yeah, the important thing is, this is why I always try to teach students how to do what is it? Stoichiometry. And this is why it's important. Because if you always have it how much I need, because students always get confused on how much, on whether they needed to divide or multiply by things. And the way to always keep it straight is to do stoichiometry, because you have like, okay, grams of something and then times, and you're like, okay, cool. I need the grams of that thing to be on the bottom, and I need what I'm trying to get, the moles, to be on the top. So that's why you divide 30 by the weight, the 98. Yeah, cool. All right, good. Good. All right. Now, Ethan, I think I'll do yours. I think yours is next. I got you. Cool. All right, let's see. What do we got time-wise? Hour and a half? Okay, not bad. I gotta go teach in 30 minutes. Dr. Gold's gotta pay the rent. Gotta pay the rent. Although I will say, I did get a, I got a callback on an interview for a job, doing, technology, computer science, and whatever content for a company. Usually I submit applications and like nothing happens, but like they actually asked for an interview, and I was like, oh, that's pretty cool. So we'll see. We'll see what comes out of that. Though I don't know how much time I'd have for doing this if I had to take a full job. Okay. Dude. Amoga's the funniest questions, dude. Okay, this is a cool one. Wait, on the size. Oh, okay. Well, okay, Ethan, we need to go over other stuff first. What's my Spotify Wrapped? Well, no, we didn't. I didn't actually teach you this yet. Okay.
Also, Dr. Gold,
What's up, dog?
you know, I really wish. Sorry, not wish. I really miss being taught by noise for physics and stuff, because yeah, it was kind of fun learning kinematics.
I agree. Yeah,
But also,
but also what? It's okay. What's up?
I want to ask you something about that. You know how in kinematics we measure stuff in seconds, right?
Yes.
Why do we do that? Why don't we measure in minutes? Is there like some accurate thing?
It's because most things that we do in physics are in like meters per second or joules per second. Everything uses seconds really to use the correct units for things. And so yeah, that's why we do everything in terms of seconds. We could do things in terms of minutes, but then all the numbers would be different. Nick, I'll talk to you later about it. Chill. Yeah. Okay. Was it Teacup said, "What's my Spotify Wrapped?" What is my Spotify Wrapped? I'll show it to you later. I'll show it to you later.
My top artist is Dax.
Dax? Who the hell is Dax? Peace, Nick.
He's the guy that made a song called "Dear Alcohol," but it's actually pretty. Some of the songs are pretty good.
Okay, that's cool. What did I teach you? Oh, I taught you forces last time. Do you remember forces, Ethan? You remember us going over forces?
Holy fuck!
I have 5
Yeah, I
hours on
remember
one
that.
song. Wow, that's a lot. 158 hours in total. 5 hours on one song. Oh, dude, I have so many more hours on things, dude. I think I'm at like lots of hours. I'm trying to think what I'm at.
Did we? I'm joking.
Anyways, yeah, I'll find my Spotify Wrap later for you guys.
Man, if you don't get the rap, that shit finna disappear. Like
Yeah, shit about right. Okay. Ethan, we're gonna go over what's called like centripetal motion. Okay, centripetal. Okay.
Centripetal.
Yeah. So this has to do with something that's moving around in a circle, Ethan. Okay. So let's say we have a car. Okay. And let's say this car like does this. It starts going around, right?
Right.
What's happening to the velocity of this car? Actually, let me represent the car as like a ball. Probably be easier. Okay. Yeah, so it doesn't like look weird. What is the velocity of this? And let's say car is moving at a constant let's say 10 meters per second. Okay?
Yeah.
What would the velocity of the car be here if I say it's moving at a constant 10 meters per second?
Are we talking initial or final velocity?
Just instantaneous, like right there.
What's instantaneous?
Instantaneous means like right at that moment.
Right at that moment for what?
Just in that instance, Ethan. Just like what's happening right there, dude.
Okay. Well, I guess it's just 10, right? Is it
Just 10.
10 still, yeah?
Thank you. Yeah, it's just 10. Okay. And what direction is it going in though? That's the question. Where's it going?
Unknown? Because a circle has no sides.
Right.
I mean,
but
unless
it's going this way, right? It's going like 10 meters per second this way.
but you didn't even say that in a question. Like, I can't.
Let's-
Moving across
let-
10 meters per second.
well,
where?
Well, yeah. Well, let's say it's moving counterclockwise in a circle.
Yeah.
Right. So here
Yes.
it would be moving 10. Okay. What about here? What happens when it's here? Where's it moving?
To the left.
To the left. Good.
Down left or something.
And to the left, right? This is 10 meters per second. Okay. What about here when it's on the left? Which way is it moving?
Yeah, down.
Yeah.
Down. Or kind of right.
No, you're good. You're good, dude. Okay. And then what about finally right here?
Just going to the right.
Good. Okay. So, is the velocity of this thing changing as it moves around in a circle?
No, it doesn't. It's just saying it's constant. It keeps going and going in that same thing.
Okay, so we got to make sure we know exactly what velocity is. So I think what you're describing is technically speed, okay? So velocity is what we call a vector. Do you remember what a vector is? You've been dealing with vectors in your math class. I know you have.
I don't know what are vectors. I mean, I've been dealing with measuring vectors in physics within
Good.
like those parallelogram thingies.
Okay, so vectors have a magnitude.
Magnitude and direction.
There you go. Very good. Okay, cool. Okay.
See, that's the thing. I learned that, and there was like two different kinds of vectors, scalar quantities and
Yeah,
vector quantities or something.
yeah, scalar quantities don't have a direction, right? Vector quantities do.
They don't have magnitude.
Good. So when we talk about the movement of something, Ethan, the magnitude is speed. Speed doesn't really have a direction, right? So in this
Yeah,
case,
it's
right?
just-
Yeah.
Yeah, it's just someone who keeps going and going and going.
Right. So you see how this is like 10 meters per second, 10 meters per second, 10 meters per second, 10 meters per second, right? That's the speed. The
Mhm.
speed is not changing, right? Okay. But what about the direction? Is the direction changing?
Yeah, it is. It
Good.
is.
See how it goes from going up to going left to going down to going to the right? You see all that?
And yeah.
Good to see you, Unaccessible. Okay, yes. So the direction is changing. And what did we learn, for instance, whenever there's a changing velocity?
Change of velocity, then
Mhm.
everything changes.
Okay. But let's think about the three things we learned about, right? We learned about x, which is position,
Or the distance, right?
or the distance. We learned about v, which is the velocity. And then we also learned about a, which is acceleration.
Yeah, and what about t, time?
Good, we're going to get to that. Okay. So velocity, right? This is equal to the change in position over the change in time,
Uh-huh.
right? So how fast you're going is how much distance you're covering in a certain amount of time. Does that make sense? Change in position over change in time.
Say that again?
So your velocity, right, is your change in position over your change in time. So like how fast you're going is how much distance is changing divided by how much time is changing.
Yeah, I get that now. I get it.
Okay. Acceleration is how much your velocity is changing over a certain period of time. Okay?
All right. Hey, is it another one of those triangle things, like with the mass, distance, and volume? Like
not
ND
quite. Yeah, I
over
know.
D equals V?
Kind of. but not quite. Not
Please,
quite.
please tell me it's one of those because that will help me out so much.
Well, I think it is something like this. So if you really wanted to, in terms of what is it? What was it? What's your? Yeah, I know what you're talking about. What is that thing? The
M
density.
over D times V. That's what it is.
Yeah, sorry. Let me see how the thing works. It's this thing, right? Yeah.
Yes. See,
I
is
never
there
understand
anything
these.
like that?
Yeah, I mean, I could make one for sure. Yeah. Let me see how that works.
Seriously though, that's the best way for me to learn.
You like learning this way? Okay. I personally don't.
Yeah,
but,
because
but okay.
hey, come on, bro. Seriously, like even though my physics ancestors they learn in different ways, I learn my own way.
Okay. Whichever way you want to learn. Okay. So if you wanted to build a triangle like this, this would be V times T, and then this would be on the triangle, and then this would be
X
delta X. Yeah.
delta X. What? Why
Yeah.
isn't there a delta V or delta T?
It would be this. It would be It would be V delta T, and then delta X there. Yeah, that's cool.
Oh, okay. So,
If you wanted
and I
to,
suppose
if you wanted to build the triangle, like if you really want to build the triangle, that's how it works.
basically it's just the exact same thing. Where if you cover delta X, you'll find a formula for that, which is V times delta. V
Yeah, no,
times
that's good.
delta
Yeah,
T.
yeah. Right. If you cross this out, you get V equals delta T. Yeah, I get that. If you cross
V
this
equal to
out,
that?
so delta X is equal to V delta T. It is. Delta X is equal to V delta T. And then, yeah, if you cross this one out, right, you get V is equal to delta X over delta T. And if you cross this one out, right, you get the delta T is equal to delta X over V. That's actually pretty cool. That's cool that that works like that. But, yeah. Okay. Okay. Awesome. All right, so we know that velocity is a change in position over change in time, and that acceleration is a change in velocity over the change in time, okay? So that's when we come here to this situation here, all right? I'm going to say that, okay, cool, this is equal to the acceleration, all right? So since this object, right, is changing direction as it goes around, its velocity is technically changing because the direction is changing, which means there is technically an acceleration experienced by this thing. Okay.
Okay. So sorry. There's some noise in the back.
Okay. So what happens here, Ethan, is that the velocity is changing. So which way is the velocity changing when it goes from here to here? Which way did the velocity go?
It went from up to left.
Good. So what's the direction of the
North to
change?
west.
Good. So the direction of the change, Ethan, that would be this way. This is what we would call like acceleration. You see how because it's going from here to here? So it's like it's changing that way. What about from here to here? Which way is it changing?
From left to down.
Good. So it's down. Good. And then here, right, this is going to be this way. And then here, this is going to be this way. This represents a cool, important concept here, which is that centripetal acceleration always points towards the center of the rotation. Yes, good. Okay, cool. All right. And even more so, we can come up with a value for this acceleration, okay? What we figure out is that AC is equal to V squared over R, where this is like
What's AC acceleration? Then?
the centripetal acceleration. So it's the acceleration that causes something to move in a circle is equal to the velocity squared divided by R. R, by the way, is
Radius.
that's the radius. Good. That is the radius of the revolution. Okay. All right. Does that make sense so far?
Yeah.
Okay.
So they give you a radius, or you have to try and find out sometimes.
No, so they'll do this. So let's say let's give you like a test question here. Let's say a 10 kilogram, or let's say 100 kilogram person runs in a circle of diameter 10 meters at a constant speed of 5 meters per second. The question they could ask you is, what is the centripetal acceleration? Okay. Do you know how you do this one, Ethan?
Sorry, hold on. I'm trying to find a calculator real quick. So so 100 kg person runs in a circle of diameter 10 meters at a constant speed of 5 m/s. What is AC?
Mm-hmm.
All right.
Okay.
So AC is still unknown, which is gonna be just AC is equal to, but we know that the velocity is 5 ms, which will
Mhm.
be squared. So
Good.
that's gonna be like 25. And
Okay.
since we're focusing on radius, we gotta divide 10 by 2, which is gonna be 5.
Good.
So that
Very
will
good.
be 25 by 5.
Good. Very good. What does
Should
that
be
give
just
us?
5. AC is 5.
5 what? What's
M
you
slash S.
m/s squared?
Dr. Go, where was Dr. Go, you just have M slash S in the problem.
Yes. Okay. But do you see how it was velocity squared? So velocity
Yeah.
is m over s. What is v squared going to be?
I don't know. Wait, B squared? In a problem?
Mm-hmm.
I don't really know.
It's m squared over s squared.
Okay.
Okay. And then we did this over r, right? Which was divided by m. So you see if you have m squared over s squared over m, that just becomes meters per second squared.
Yeah.
Cool.
Cool.
Yeah? Okay. Good job, Ethan. That's a good starting. We're getting closer. And then probably like the next one we're going to do like the actual question, but I want you to like learn like gradually. Cool?
Cool.
Awesome. All right, nice. Okay. All right. I still got time for questions, I think. Yeah, Tika, what's up? You said let's see your Spotify Wrapped. What's this? Who's Spotify Wrapped is this? Who's am I watching?
Hey, Dr. Go.
What's up, dude? Oh wait, this is my Spotify Wrapped.
You know,
What's up?
so you remember that good grade coin you sent me?
Yes.
You gave me 2 of those 2 times. Like
I know.
you gave me 2 coins for 2 different ones.
Yeah, I
So
know.
why?
Cuz I gave you a bonus. Cuz you're doing well.
That's it. Why?
Cuz you're doing well. Like I appreciate when students are like, making positive improvements and whatnot. Like that's why I gave you a bonus.
Seriously, though, it's like
Like if most kids just post like they're getting hundreds in their classes, like cool. Like I limit that. But if you're showing me that you're doing progressively better in your classes and you're showing up all the time and I'm helping you out with things, then yes, I reward that more. That's how this works. I don't it's not it's not written it's not written in the rules anywhere, but like I'll do it sometimes. I always make exceptions.
all right. So Dr. Go, see, I want to tell you something.
What's up? There's
So
my
ever
Spotify
since the
Wrapped.
start of the school year, when I would have work, my mind will always be stressed out and like, what am I gonna do and what am I gonna do?
Okay.
Like, how will I be able to complete the proof in this amount of time? And then in the end, I completed. But now, one day, for some reason, my mind is just all calm now. It feels fuzzy.
So you said your mind feels calm and is fuzzy? What is that? Sorry, what?
Kinda, it's like now when I get work, it's like my mind's not even stressed about it.
Oh, good. Yeah. Yeah, I'm glad you're not stressed. You shouldn't be stressed all the time. Stress is like not a good thing on the body. Yeah. But I mean, are you
it seems-
still getting your work done though? You're still getting stuff done?
Yeah, I'm still trying to get stuff done.
Okay, nice. Good. My brain is fuzzy in a bad way. Uh-oh. Oh no, Falcon. I mean, my brain feels cloudy too sometimes, man. Like, I have like rough weekends. Like, it happens, dude. Has been since COVID. Yeah, COVID's real, dude. Long COVID's real. What's up, Ethan?
Is Noise still around?
Noise is still around. Yeah, you can ask him nicely to you know, teach you some physics. He's kind of busy with girls these days. That's what happens, you know.
Oh my goodness. Huh.
I
It's getting
know.
numbers, huh?
I know. And like, dude, I have my own opinions on like the girls he's like occupied with, but it's okay, you know.
Honestly, you know, not to go, I really can't. Now I feel like I really can't live without physics.
You can't live without physics?
Yeah, it's like it's always so cool to actually like, how do you say it? It's always so good to pick up a pen or pencil and then you pick up a calculator and you start doing calculations all the time.
Yeah, I mean it's dope, yeah. One sec. Okay. Yeah, I'm glad, dude.
Where can I tag him?
You can tag him in the. Are you in the vectors chat or something? Aren't you in one of the vectors chats or something?
I have vectors turned into the common area.
Common
And
noise.
Vectors
Yes.
I love vectors.
Yeah, the one that says
And
turned into
vectors are
the
like-
one that turned into common area. That's the one you want to tag him in. Tag him in that one. The difference is staggering.
Alright.
Falcon, what do you think causes that jolt in your concentration, dude? What is it? Curious. For me, like exercising well and like not eating garbage tends to help. It's when I eat like sugar and stuff that like my brain goes fuzzy. I don't like it. Unaccessible's back. What's up? Okay, here, Teacup. Let's do your question. Come up the stage, Teacup. Teacup. Did you ask me a question, Teacup, too, by the way? You just keep asking, like, random questions. Teacup. Here. I had to go talk with my parents about sweating bullets. What happened, dude? What happened during your parent-teacher conference? Oh, that's cool, Falcon. Yeah. Yeah, when you have, like, this moment of, like, you're just, like, interested. It was digital? Oh, it was, like, online? It was an online parent-teacher conference? That's kind of lame. Yeah, that's whack, dude. Screw that. Feedback and stuff about my behavior. Okay. Yeah, that can be worrisome sometimes. You're like, what do my teachers think about me, right? I've had that before. Because in my old school, I would do that, but now I do great. Dude, that's awesome, dude. And you're in honor classes. That's awesome, man, dude. Great. I'm glad. I'm glad you're all doing better. That is heartwarming to me. Yeah. Yeah, dude, and like, again, you're doing the right thing. You know, anytime you need help with, you know, any of your math or science stuff that like doesn't make it that much sense, or like the teacher didn't explain it right, like, come on by, let me help you out. That's what this is for. I don't know how much longer I'll be able to do this. That's what I'm getting at. I have a lot of other stuff I gotta start doing in life, and I'm trying to help you guys as much as I can while I can. Yeah. Okay, cool. Well, I don't know where Teacup is, so I'm gonna end the office hours because I gotta teach in 10 minutes. All right. Thank you, everyone, for coming to office hours. Had a good time doing all the questions today. Yeah, we had some tough ones. I'm sorry. I'm sorry if you got maybe a little bit bored there. It was we had a lot of tough questions, which is okay. I like it. I like a struggle. It's fun. But yeah, I won't be able to stream for the rest of this week. I gotta I gotta go now. Teacup, I tagged you, dude, but I gotta go now.
Oh damn.
I know, it's okay. But yeah, I won't be able to stream the rest of the week because I gotta go to I gotta pick my parents up from the airport tonight, and then I gotta go to a wedding on Friday. So and then I'm driving down to this wedding place tomorrow. So next stream will be on Monday. Same time as always. You know, that's gonna be 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. Come on by. Let me help you out. Do well in your classes. Do well in your exams. All that good stuff.
So minor question.
What's up, dude? What's your minor question?
Does that mean you don't have time to review the essay?
When's your essay due?
Friday.
I'll have time before Friday. That's okay. What time on Friday? Can you do you make sure to tell me what time on
like
Friday?
11:59 p.m. on Friday.
Your time, 11:59 your time, right?
EST.
Okay, cool. Yeah, I can probably get to it tonight or tomorrow. If I don't, ping the shit out of me tomorrow, okay? And I'll make sure I get to it.
I'll harass you.
That's okay. Yeah.
I
Yeah.
sent you all the rubric and stuff.
Yeah, I appreciate that. That's good. That's good for me to go through. I'll be able to figure it out. I got so many pings and all this stuff, dude. What's going on? Oh, look at all these pings. Listen to Sam. Who is Sam? Yeah, everyone knows who Sam is. Okay, cool. All right, I gotta go teach a student for their circuits class. So I can't play video games today, but maybe I'll Justin, I'll hit you up if I can play later tonight or something for you. Is that cool? Okay, cool. All right. Enjoy the rest of the week, guys. Enjoy your Wednesday. Live life. Have fun. And I'll see you guys around. Peace.